Hello everyone, and welcome to another session of RedisConf 2021. In this session, we will for the first time publicly announce a new project that we've been developing for over a year now and will soon be generally available to our customers as part of Redis Enterprise. Of course, as the session name indicates, I'm referring to RedisCDC, a standalone, lightweight data platform that can seamlessly integrate and continuously replicate data between heterogeneous data sources and targets. Are you interested? All right, let's dive in. My name is Alan Terleto, and I have the privilege of being both the field CTO at Redis Labs, home of Redis, and leading a team of very talented field engineers, including Virag Tripathi. Virag's been a primary driving force behind this exciting project and will demonstrate its use as part of this presentation. He has many years of deep experience in the messaging, data integration, and streaming space, so we're in good hands, and I think you'll like what he's got cooking for us today. For those of you wondering what CDC means, no worries. We'll intro it in just a bit, followed by a high-level overview of RedisCDC's architecture and capabilities. Once we cover how it works, we'll talk about what problems it can actually solve. From there, Virag will walk us through a hybrid cloud deployment demo, which uses RedisCDC to continuously migrate change data events between an on-prem SQL Server database to an active Redis Enterprise database deployed both on-prem and the cloud. That should be exciting, so I'll try to go through these slides as quickly as possible. After the demo, I'll come back to make a few announcements regarding what's next with RedisCDC. So, without further ado, let's begin. CDC is an acronym for Change Data Capture, which is actually pretty self-descriptive. It's a process for capturing change data events, which within this context boils down to create, update, and delete operations that originate at the source. The source is typically a legacy relational database, but can also be a NoSQL database or even a file-based system. A couple important things to point out here. First, reads are not considered change data events, since the state of the record has not been altered. This means they are not registered by the internal change notification triggers and therefore not captured by the CDC process. Second, in most cases, the CDC process is natively supported by the source database itself. Here's why this matters. By integrating with only the output of the native source side CDC process, which is typically a log, RedisCDC can seamlessly consume change data events without impacting the performance or risking inconsistency with the source side transactional system. We'll talk more about this in detail as well as other noted characteristics on this slide once we dive deeper into RedisCDC's architecture. For now, simply think of CDC as a bridge that facilitates continuous motion between a point of origin referred to as a source and some destination referred to as the target. All right, let's now take a look into how that continuous motion we just mentioned flows from that source to target. As you can see, flowing left to right, RedisCDC can consume change data events from different types of sources. This includes relational databases, NoSQL databases, legacy data grids, and even file-based systems. Once consumed, change data events can be transformed or enriched before being published to one or more targets by RedisCDC. For example, a popular use case is to use RedisCDC to continuously replicate change data events from a relational database to a Redis hash or string or JSON model. Since relational databases rely on SQL, it's not a surprise that users for this use case predominantly rely on Redis search for real-time SQL-like querying based on secondary indexing. However, let's not forget that Redis Enterprise is a multi-model database. So basic Redis data structures are not the only model supported. By using RedisCDC to implement the event sourcing pattern, with Redis streams acting as the event store, we can register Redis gears to listen to a Redis stream and propagate change data events to their final destination, whether it be Redis time series, Redis graph, Redis AI, or whatever your specific data pipeline might require. Now that we know how data flows, let's go one level deeper and see what's actually happening under the hood. We're going to get a bit technical here. Let's start this time in the middle. RedisCDC has a Java-based, cloud-native, shared-nothing architecture, which means that it is infrastructure agnostic. And every instance or node within the cluster has all the necessary facilities to operate standalone or become the leader of a cluster topology. You will notice that we are eating quite a bit of our own dog food with this platform. We did this purposefully to keep this platform lightweight, so our customer base doesn't need to add any more complexity into their architecture. No Zookeeper, no Kafka, no external time series database. If you already purchased Redis Enterprise for some business purpose, then you have everything you need to operate RedisCDC. RedisCDC's architecture segregates the control plane from the data plane. You can see the services of the control plane at the top responsible for cluster management and managing job ownership, and the data plane at the bottom, which is responsible for job execution. So each instance of RedisCDC can handle both cluster management and process an entire data pipeline end to end without any impact between those concerns. Now you might be saying, well, what's a job? That's an important question. RedisCDC jobs are configurable event-driven workflows which transition state across multiple event processors, each representing a separate workflow stage. Jobs are executed end-to-end within the same RedisCDC instance to reduce network I/O, context switching, and JVM garbage collection pauses. This design allows for predictable resource utilization, optimized performance, and clean failover between RedisCDC instances. In fact, RedisCDC is so efficient that most production deployments simply require a VM with 4 vCPUs and 8 GB of RAM, maybe less. A typical workflow only requires a few stages. However, since RedisCDC is a highly configurable and extendable framework, users can add additional workflow stages for complex transformations, things like tokenization or data masking, or add on custom user-defined business logic into the data pipeline. All of this is entirely configurable, and custom code can be added onto an extension folder, so it remains completely private to the user. As depicted on the bottom of the diagram, each workflow is initiated by a change data event producer. The producer is encapsulated within what we call a RedisCDC connector, which is purpose-built to the nuances of the source. For example, we have connectors for SQL Server, Gemfire, Postgres, and I'll announce more at the end of this presentation. The connector acts as the integration point with the source by consuming batches of change data events and publishes them into RedisCDC's event-driven data pipeline. Again, you can see that at the bottom of the diagram. As the events are processed in real time across the pipeline, it blocks consumption of the next batch, which acts as a circuit breaker in the event of a network disruption or unplanned availability of the target. The goal here is to avoid duplication or data loss. Now you might recall that I mentioned our goal with RedisCDC is to integrate with the output of the native source side CDC process. This is what we mean by a seamless integration. As depicted on the left, that output is typically a write-ahead log or a transactional outbox table. We're not going to go too deep into either of those data structures in this session, so for now let's simply describe them as segregated immutable logs that are dedicated to capturing changes in the exact order they were committed at the source. Typically, the creation of this log is enabled by a DBA for a pre-configured set of tables that require change data capture, so not normally the entire database. As you can see on the bottom right, the final workflow stage is typically a target writer, which is responsible for committing change data events and updating the checkpoint to one or more Redis Enterprise databases. Checkpoints are used for offset management, which is required to maintain continuity, order, delivery guarantees, and resiliency in the event of a failure during job execution. This is to make sure, in the case of a failure, RedisCDC can pick up exactly where it left off without skipping a beat. Once all workflow stages are completed, the change data event producer is unblocked to publish the next batch of events into the data pipeline. I think the only thing that I didn't cover was the use of Redis time series for RedisCDC management and metrics database. I'm going to cover this in just a bit. All right. Now that we have an understanding of the high-level architecture, let's transition to some functional and also non-functional capabilities. As you can see, we've actually covered quite a few of these already. For example, if you look at the bottom tier, you're going to notice that we covered RedisCDC jobs are customizable, event-driven workflows that are composed of event processors, which are configuration-driven and extendable. At the top, you might remember we already mentioned that RedisCDC is real-time. It's cloud-native, seamless to integrate, and has a growing set of connectors that I'll highlight after the demo. Something we didn't cover is that RedisCDC is supported by Redis Labs as part of the Redis Enterprise license. This means Redis CDC will be covered by the same contractual SLAs and customer support Redis Enterprise customers know and love. This leaves us with the middle blue tier. Let's dig into this a bit here. I mentioned earlier that Redis CDC jobs are executed end-to-end within the same Redis CDC instance they were initiated. This is because events flowing through a job's data pipeline are completely transient. That is until they are committed to the target database and the checkpoint is updated. If a Redis CDC instance was to fail before updating the checkpoint, a backup instance would pick up right where it left off. So data is not lost and the order is maintained. This means that checkpoint and other job-related metadata is critical to the availability of Redis CDC. Not to mention, we need to access and update that data in real time, so checkpointing doesn't become the bottleneck. This is where Redis Enterprise plays a critical role in this architecture. With Redis Enterprise, we can update and access the checkpoint in sub-milliseconds and leverage all the operational excellence of 5 nines availability, persistence, security, and more. Now, a few words about ease of use. I already mentioned that Redis CDC is entirely configurable, which means you do not need to write any code to deploy a mission-critical data pipeline between your source database and Redis. However, if custom business logic or complex transformations are required, it's easily extendable. Adding an additional stage to the data pipeline is as simple as extending a single Java class and adding it to the extension folder. What about observability? If you recall, I mentioned that Redis CDC's management and metrics database uses Redis time series. Like everything else, this is configurable. However, if you do want observability, we take advantage of this purpose-built time series model since it's a perfect fit to ingest data pipelines metrics in real time and exposes them using our new Grafana Redis data source. We'll see this demonstrated in just a bit. All right, that was a lot of tech talk. So let's now take what we discussed and apply it to some real-world problems that our customers are trying to solve. Let's begin with the ones that get the most hype, database migrations. To simplify things, let's separate migrations into 2 categories: one-time migrations and multi-phase migrations that can span over a year. For one-time migrations, we commonly see customers attempting a blue-green deployment, where for some period of time, both the new and old deployment are available in parallel. Once the customer is confident with their new system, they have a hard cutoff for that legacy deployment. Redis CDC is a really good fit here, since it can maintain consistency across both blue and green deployments until eventually cutting off replication. Now, in the case of a multi-phase migration, let's say such as a strangler application, where we are breaking off microservices from a monolith legacy database, Redis CDC can maintain consistency between those heterogeneous databases for years until the monolith is eventually retired for good. We're also seeing a lot of demand within the analytics space, with customers that want to perform intraday real-time ETL. In this case, Redis CDC is used more as an initial loader, which requires it to partition its consumption of source-side transactional data so it can finish its ETL process within a thin SLA window. This is where another nice feature of Redis CDC is a value add. For initial load jobs, Redis CDC can spawn child processes, which can in parallel consume partition data from the source. The partitioning strategy can be configured to fit the SLA window for the ETL job. Another interesting use case within analytics is building denormalized views for real-time reporting, alerting, and visualization. As I mentioned earlier, Redis Search is commonly demanded alongside Redis CDC, so it's not a surprise that it's typically used here as well. Let's discuss the use cases I skipped on the following slides so they are easier to visualize. Here we focus on 2 very popular patterns of the day: microservices CQRS and cache-prefetching. The concept here is simple. We have a system of record that ingests all the writes, otherwise known as a command. However, for cost or performance reasons, it needs to offload its data into a segregated real-time database or cache, otherwise known as a query, which is read optimized. So how do we do that without performing a dual write at the application layer, which comes with overhead, code complexity, consistency concerns, and is generally an anti-pattern in microservices architecture? Well, we use Redis CDC to seamlessly integrate, transform that data from a write optimized to a read optimized data model and allow Redis Enterprise to serve it to you in real time. If you're interested to learn more about cache prefetching, there is a separate session by the Bountiful Company, which I highly recommend at RedisConf. They will cover how Redis CDC helped them easily solve cache prefetching between Redis and SQL Server. Finally, let's talk about hybrid cloud deployments. There's a lot to unpackage here, so let's simplify this down to 3 problem statements and solutions. First, how do we seamlessly replicate data from our legacy operational database, which might be anchored on premises for the foreseeable future? Well, RedisCDC is the obvious answer. Second, how do we get that data from on-prem to the cloud? Well, RedisCDC can replicate change data events to an on-prem active-active Redis Enterprise database replica, which will instantly propagate those events to its mirrored replica in the cloud with conflict-free resolution. Third, can the cloud deployment within this hybrid solution be deployed as a managed service? The answer is yes. Redis Enterprise is unique in its ability to bilaterally replicate change data between active-active clusters, deployed on-prem, as a managed service, or even multi-cloud. With that said, let's finally see this in action. At this point, I have the privilege of handing it over to Virag, who will show us what this could look like. Virag, the floor is all yours.
Thank you, Alan, for the great overview of Redis CDC. As Alan mentioned, I will be showing you Redis CDC in action in this demo today. I'm going to use SQL Server as the data source for Redis CDC and an active-active Redis Enterprise database, also known as CRDBs, which stands for conflict-free replicated databases, with 3 member replica sets, as you can see on the screen, distributed across 3 clusters on different subnets as the target. CRDB provides 3 fundamental benefits over other geo-distributed solutions and many more. It can offer local latencies over read and write operations. Right? It enables seamless conflict resolution for simple as well as complex data types like those of Redis core. Even if the majority of the geo-replicated regions in CRDB, for example, 2 out of these 3 clusters are down, the remaining geo-replicated regions are uninterrupted and can continue to handle read and write operations. And that's how we handle business continuity. It can also be used for disaster recovery purpose. Now let's dive into the demo. And to start off with, I'm going to show you what we have on the source side. Right? So source is set up with a table that is enabled for CDC. It's called EMP. Right? Let's check and make sure the table doesn't have any record since we are starting from clean slate. So as you can see, it has 0 records. Now the target being Redis, as you're seeing it on the monitor. I'm also running CRDB top command, which shows you the metrics around multiple replica members of the CRDB. And you can see the keys are 0, right? We can also see it in Redis Insight, which is a client UI tool. And you'll see it here, Redis target DB1, which is the first replica, has 0 keys. Then DB2, replica number 2, DB3, replica number 3. They all have 0 keys. And what you see here is the job management database where we would be storing the job configuration data and the metrics data for monitoring purposes, which gets captured using Redis time series. And then we'll be plotting that using Grafana, Redis data source. Right? So let's start the seeding the job config data. So for that, let's switch the window to the SQL Server connector, and we will run this process to seed the job config data. Right. So let's go ahead and start this. Let the process finish. Now let's go back to the browser. We are seeing 9 keys. We come to browse, and you'll be seeing all the metrics keys, the job config key, which holds the job data, right, and all the other job details. And as you can see, the job owner is unassigned because we haven't started the CDC process yet. So let's go ahead and start the CDC process. And we'll be passing the true variable, which tells this Redis CDC instance to mark this CDC job for job management purpose as well. So job management is enabled on this instance, and it will be captured in the job management database. Right. So let's go back to the browser and refresh. The job key should be getting a job assigned, but it takes about 10 to 20 seconds for this to happen, because that's the heartbeat we have provided, right? That can be changed as well. Everything is configurable in RedisCDC, as Alan mentioned. So in the meantime, let me show you the source database and how it has been set up. So database is created, right, and enabled for CDC. And then we have created the table with this EMP table with these columns and a primary key, and then enable them for CDC. Right? So you can run a store procedure to check if the CDC is enabled properly or not, right? And this gives you the output. Now let's go back to the browser. This should have the job now, right? So job is assigned. Now we can start sending the change events, right? So for the first round, let's go ahead and send some insert, update, and delete, right? So to begin with, I'm going to send these 11 records. And one more thing I wanted to mention here, what you're seeing here on this data center window is these three replica members of the CRDB. We are doing running monitor command on each one of them, right? And this would be basically showing as and when we make the changes, right? So we are running monitor, and we are also filtering for the output we are interested in. So we are looking for those commands. So let's go ahead and send these 11 records. They will be inserted in SQL Server and immediately get picked up by Redis CDC, and boom, we have the records on the CDC on Redis in all replicas, right? So same thing we can observe in the browser as well in Redis Insight. If we go to the target, we should see all these 11 keys from EMP1 to EMP11. And this is the checkpoint key, as Alan mentioned earlier in his presentation. This is where we maintain the offset for data integrity purpose and sequencing, right? And you should see the same data across all these three replicas. Right? Now, this data can be searched upon as well using Redis search, right? So we can execute query, right? And we should see all this data. One more thing I want to mention here about the time series, how we are capturing the monitoring metrics data, right? So this can be queried as well. And I'll be showing you in the Grafana, but for now, if we run this query, which we are querying for all the inserts we just did. So we did 11 insert, and we can query that using the time series command. Right? Now that we did the manual insert, let's go back and do some more changes. So let's go ahead and update a record. We'll pick EMP number 3, right? So let's go back and check what is EMP number 3. Right, it is Drake. Let's go ahead and update salary of Drake. Done. Right. We come here, we do refresh, boom, we got the change. Right. Let's go ahead and send a delete event as well. Right. We'll go ahead and delete EMP number 3. And come here and refresh. Now EMP3 is missing. Same thing if we go and do a Redis search query, we should not see EMP3 here. Right. Now we will be doing sending the change events in a continuous fashion. And for that, I'm going to use a loader utility that we have and constantly sending insert, update, and delete events. So let's go ahead and start this. The utility is running, right? And you will see the data keeps flowing through this monitor window as an how we are making the change events, right? So as insert, update, deletes are happening, it is being captured by Redis CDC, getting transformed to Redis hashes, right? And those are the changes you are seeing in this transaction log. Now let's go back to the browser. You should see all the keys coming here as well, right? 389 keys here, 441. This should be getting synced, right? Now to see a better view of this, we'll go switch the window to CRDB top so you can see the key changes happening in real time and getting synced across multiple replica sets, right? As and when changes are happening, as you can see, the keys are being changed in all three replica sets. Now let's go ahead and show you the Grafana dashboard as well, which we have created using Redis Grafana data source. I'll refresh this window. And this should be getting all the changes as we are doing a continuous change using the loader program, right? So this is receiving all the insert, update, and delete events as and when they're happening. And you're seeing the throughput plotted here and the overall latency, right? At the bottom half of this window, you'll see the target metrics. Right? So you saw how easy it was to send the changes from SQL Server and received by Redis CDC, then replicated to Redis databases. We can also search on these data. Right? Well, that's all I have for now. Hope you like the demo and feel free to ask any questions you may have. I'm going to hand it over to you, Alan, now.
All right, that was excellent. Thank you, Virag. Redis CDC, SQL Server, Active-Active, Hybrid, Redis Insight, Grafana, Redis Time Series, Redis Search. That demo had a little bit of everything. Cool stuff. I hope you guys like what you saw and are wondering when you can get your hands on it. Also, what connectors we support. So let's cover that. Redis CDC will soon be available as public preview to our customers for SQL Server with an expected GA sometime this summer. As you can see, we are not constrained to just SQL Server. We have Oracle, Postgres, MySQL, Gemfire, Cassandra, and more already in private preview. Since we have different levels of demand from our customers for each connector, they will all follow their own release cycles. So do look out for periodic announcements as these connectors each mature to public preview throughout this year. There's a lot more goodies coming, such as a REST API and CLI, and even down the line, a web UI. So stay tuned. I'd like to conclude by highlighting a quote from the presenter of the Bountiful Company's RedisConf session, since it encapsulates some of the value that Redis CDC brings to our customer base. The ability to seamlessly integrate between legacy databases and Redis Enterprise can really be a game changer to your business agility and digital transformation. Whether you are solving cache-prefetching, implementing microservices patterns, migrating from legacy databases, or are just looking for a seamless hybrid deployment solution. Finally, I want to thank you all again for your time today. I genuinely hope you enjoyed this session, see value in what Redis CDC can help you solve, and I look forward to follow-on questions. I also want to express a special thanks to the many people behind this project, including Ivoyan, who's been a strategic partner in the development of this platform, our early adopter customers, the CTO, solutions architect, field engineer, and PM teams, and of course, a special thanks to my co-presenter, Virag Tripathi, who's been the heart and soul of this project all along the way. Cheers, and enjoy the rest of the conference, everybody.